Hi, grade 12. So let's continue with the March 2025 paper um, that was set by the Free State Department. So we are at question 3. Now, the first thing that I told you that you should be on the lookout for is um, what type of question are we working with, right? So in question 1, we had algebra and exponents and all of that. And then now in question 2, we had sequences and series. And now we have to look at question 3 to see if we have anything that might actually help us in or on the formula sheet, right, that is provided to us. So as we quickly scan through this question, you would see that fx, they give us fx equals the square root of x over a with a limitation over here, and they give us a point. So we can immediately see that this is functions, right? And then in grade 12, we know that we aren't just going to get a grade 10 and 11 functions question. We are going to get functions and inverses, okay? So as you could see, that's over here in question number 3.2, they talk about the inverse. So we know that we are working here, or this question is going to be about the chapter functions and its inverses or their inverses. Okay, so this is where our head should be at. And now the difficult thing about this, right, or the sad thing for you guys is that there aren't any specific formulas that you can go and highlight on your formula sheet to assist you with the work ahead for the math that will be asked of you lying ahead. So you will have to focus on all of your math principles. So your tools for answering this question is going to be based on what you studied in your book about this chapter, and also your previous knowledge, and then all of your limitations, your inverses. That's very important. Okay, so you will have to rely heavily over here about your math principles that was taught to you in class, and also please keep your focus inside of your books as well before you walk through any papers, because that's what's going to get you through this. Okay, so that's basically what makes functions and inverses a bit more difficult than the others. There are no formulas that you can just start with. Okay, but let me try and explain this to you in a way that after you have watched this video, that you will have the principles that you need for future questions. Okay, so let's get started with quickly reading through this question. Okay, so they give us the formula or the function f. Okay, so they say that fx equals the square root of x over a. Okay, so that is basically what they say. So fx, that's my function notation, that equals the square root of x over a. Now we stop over there, guys. We have to take this step by step. So you first have to tell yourself, listen, in grade 10 and 11, we taught you that when you see the formula for a function, you immediately have to classify it as an exponential function, a parabola, a straight line, you know, or a hyperbola, right? So those that was taught to you in grade 10 and 11, and that's the first thing that you had to identify, right? So the same thing over here, but we're working with inverses as well. So now you also have to identify when there's an inverse of a parabola, or when it is an inverse of an exponential function specifically, or a straight line or whatever, okay? So here you will see that we will be working with the inverse. When we work with a square root function, we are working with the inverse of a parabola. Okay, so this will then be the inverse of the parabola. Okay, do you understand? That is what you need to know when you see this. So when you see this in the test in future, okay, fx, hx, gx, kx, whatever, equals, your function notation equals the square root of something, okay? And there can be a plus or a minus outside the square root and also inside the square root, okay? But it doesn't matter. That is then the inverse So let me just add that the inverse, it's E, the inverse of a parabola. Okay, so that's the first thing that you had to have written down when you saw this. Then we know we work with limitations. Okay, when we work with functions and their inverses. Okay, especially guys because we work with a square root over here. So we know, guys, that when we work with square roots, right? We know that whatever is underneath the square root cannot be positive because then the answer would be non-real, okay? It would not exist. The function would not exist if the answer of this fraction would be negative, right? So therefore, we have to say um, they tell us over here that x is smaller and equal to 0. We will see just now that y, because they say x is smaller than 0, right? So that means x should be negative, okay? But remember, we also have a value for a, okay? And you would see that because x is negative over here, you would see that the value of a, when we calculate it in 3.1, will also be negative, and that will then make our fraction positive. Okay, so that is why x should be smaller and equal to 0. So don't worry about this, guy. Okay, actually worry about it. It's very important. But this is then called your, just know that this is your limitation. Okay, that's your limitation. And remember, your limitation will always form part of your calculations and your inverse as well. Okay, so what happens is, remember that when you do your inverse of the specific function, you have to remember that you also have to change your inequality as soon as you change your x and y, or when you get the inverse. Okay, so that is extremely important. Okay, then they say that the point, let's just highlight the inverse. So that is the, the limitation. Okay, so we have our function, which is the inverse of the parabola, and we also have our limitation, and we understand why we have this limitation, and it's all because of the square root. It's under the square root, and we cannot have a negative answer underneath the square root. Then they say the point P, -8 and 2 lies on F. Okay, so they give us a point on the function of F. Okay, so that helps a lot. So that's our information for question number 3, and now we are going to have to answer the questions. So let's fall away with question number 3.1, and all they ask over there is determine the value of a. So we need to determine the value of a over here, and the value of a, guys, we can see that a is within my function itself. Okay, it's in the formula for my function. Okay, in the equation of my function, you would find a. Okay, so we need to isolate a to get a value for a. Okay, and to be able to have a, our only variable, our only unknown, we need to replace y with a value and x with a value, so that only a is our unknown, and then we can isolate a, and then we can solve for a. Okay, so that is our plan. And to replace y and x with a value, we can always substitute a point into the equation. Okay, and that's exactly what we are going to do. So we are going to substitute, okay, point P, right, which is -8 and 2. We are going to substitute it into F. Okay, so into F, we will be substituting the point that was given to us. Guys, when a point is given to you, please always consider that you need to substitute the point into your equation to solve an unknown. Okay, so let's do that. So we know that fx basically represents our y value, right? Okay, so we are going to replace fx, our y value, with the y value of point P, which is 2. So you are going to say 2 um, equals, and then you are going to write the square root, right? And we are going to replace our x value with -8, okay? So -8, and then that would be A would be my denominator in my fraction underneath the square root, guys. So can you see we have substituted point P into my equation? Can you see now the only unknown is A? Can you see that? So that is a tool that you can use in the future. Actually, it has been taught to you since grade 10. So please remember, when a point is given to you and you need to get another unknown or any unknown, always consider substituting that point. So now we need to isolate A, and this is pure algebra. So let's get started. So we need to isolate A, but A is underneath a square root and also part of a fraction. So we first need to solve or get rid of the square root. And to get rid of a square root, we just put brackets around this term or around the square root and we square it, okay? And what we do on the right-hand side, we also have to do on the left-hand side, right? So the square root, so the square and the square root would cancel. So what is left then on the right-hand side is negative 8 over A, and then 2 to the power, or 2 squared is 4. Okay, so now to get A alone, we just basically need to get rid of this fraction over here because A is a denominator. We don't want A to be a denominator. We want A to be isolated. So to get rid of this A as the denominator, we just multiply by A, okay, because then that and that would happen, right? So then we are left with negative 8 on the right-hand side, okay? But what we do on the right-hand side, we also have to do on the left-hand side. So 4 times A would give you 4A, okay? And then to isolate A, we know we need to divide by 4, okay? And then you would get that A equals negative 2. And there you have your value for A. So guys, this is definitely going to be a green question. Yeah, because we have taught you since grade 10 that when we give you a point on a function, to get an unknown, you have to substitute that point, okay? And then the algebra wasn't difficult, so your answer is then A equals negative 2, okay? Now we just have to know that the value of A over here then has to be substituted with negative 2. Okay, please know that because that's important for 3.2. Okay, so what do they ask us in 3.2? So in 3.2, they ask us to determine the inverse of f. So determine the inverse of f. Okay, so inverse means that x and y needs to swap. Okay, that is what the inverse means. Okay, so let's just go and do that. That's the very easy principle of the word invoice. So you invoice, sorry, inverse. Okay, so you have to swap your x and y. That's the only thing. So how do you do this, guys? It's always best to first go and write your the equation for fx. So first go and write the equation that you need to get the inverse of, and that is fx equals the square root of x over, remember we just calculated, please do not write a, okay, you just calculated a value for a, so it would be x over negative 2, okay, but guys, please remember this, together with this, you have to write, and this is something that you guys forget, you have to write the limitation as well. The limitation goes with the function. So please remember to write your limitation. Otherwise, you are going to forget to do the opposite of this inequality when you get to the inverse, and you will lose that mark. Okay, so just go and write it exactly as it is, and then you can go and do the rest. So the next step that you have to do when you get the inverse, after you have written the original function as it is by replacing the value of a with negative 2 is you need, please just go and do this simple thing. It's taught to you in class also, that go and replace the function notation of fx with y. Okay, so just go and change the fx to a y, okay, because that's going to make it easier for you to just swap around x and y, okay? And then you just leave your limitation over there, okay? All we did is we changed fx to y. Okay, that just makes it easier for you because now you know that you need to change your x and your y around when you get to your inverse. Okay, so now you can actually go and write, we are going to get to our, when we start working with our inverse, we can swap x and y around. So we can go and say that x equals the square root of y over -2. Okay, can you see that? So you basically you are saying we are busy, we are doing the inverse now. So we swapped around the x and y, and when we swap around the x and y, we also have to change our inequality from smaller than to greater than. And there you will get your mark already by changing your inequality. There's already one mark out of three. Sorry, you actually at this stage, you already have 2 out of 3. By swapping around your inequality and also by swapping your x and y. Okay, but this is not your final answer. Remember, we need to get the inverse, and the inverse should also be a function. So the inverse of x is also going to be a function because of its limitations. So therefore, you always then, after you have swapped around, guys, after you have swapped your x and your y, the next thing that you do is you need to isolate y, because that's what we do with functions, right? I should always be on the left-hand side and the rest on the right-hand side. Okay. So therefore, we need to isolate y and get y on the left-hand side. So let's do that. So remember, once again, we have a problem over here, right? Y is underneath a square root, okay? So to get rid of it, we need to, okay, we need to square both sides to get rid of the square root. So that and that would go. And then we are sitting with x squared equals y over -2. Do you agree with me? And then you can keep writing this limitation, okay, to not forget about it, okay? So now we are getting closer to isolating y. Can you see that? To get rid of, or to isolate y, we need to get rid of this denominator of -2. So that then means we have to multiply by -2 because then that and that happens, and then we have y isolated. But what we do on the one side of an equation, we also have to do on the other side. So we need to multiply by -2 over here, and then x squared times -2 is -2x squared. Okay, and then with your limitation also, x is greater and equal to 0. Okay, so can you see, guys, now you have your full marks. Okay, so you get 1 mark for actually just swapping around your x and y, 1 mark for changing your inequality, and then your final mark would be for isolating y. And then I would always suggest, because they gave it to me or they asked the question in function notation, I would go and write it as the inverse of x, okay, is then equal to -2x squared. And then you have to go and write your limitation as well. Okay, but if you stopped over here, if you stopped over there, you would have gotten your 3 marks, but I would suggest that because it was given to you in function notation, that you would go and write it in function notation as your final answer. Okay, so now we know, right, that this is a parabola. Can you see it's x squared? We know we have to look for ax squared plus bx plus c. That's the formula, or the standard formula for a parabola. Okay, so and we also said over here when we started that our studies of functions and inverses tells us that when we have a function with a square root, it's the inverse of a parabola. So they asked me for the inverse of this function, so we expect it to be a parabola, and that's exactly what it is. And now we have to think, right? Because when you go to 3.3, you would see that they are asking you, okay, let's first just the inverse. The inverse is just swapping around. I just want to determine if it's going to be a green question, okay? Or do you know what? Let's make this a yellow question, just because of the fact of the limitations, and that you might have forgotten your limitations, and that you might have lost your mark over there. So please remember that your limitations always has to go with your function itself, okay, to get full marks. Okay, now we are moving on to 3.3. They want us to sketch both the graphs of f, okay, my original function, and my inverse, which is my parabola, on the same set of axes, and show at least one point and the intersects of each graph for 4 marks. Okay, so I would also make this one yellow, because you would see there were certain things that you had to study to be able, or actually use your math logic to be able to draw this properly. Okay, so let's just move down. Okay, so we know, let's do this first. So we know that this one is going to be the parabola, right? Okay. So this is the easier one. We've been doing this since grade 10. So let's just have a look at this parabola before we go and draw so that we have some expectations. We know that this parabola, can you see that it is negative 2x squared? That is the formula for this parabola. So because it's negative, because the value of a is negative, we know that our parabola would be frowning, okay? So that is how it's going to look. And also remember that if there's no bx plus c, because when you think about the standard formula, it's y equals ax squared plus bx plus c. Can you see there is no bx plus c? There's only ax. So that means when there's no bx plus c, it means that the turning point would be at the origin. Okay, that's what that means. The turning point would be at the origin. Okay, so that is exactly what we can expect over here, or that's what's going to happen, that the turning point is going to be at the origin for both the parabola, the parabola and its inverse function, which is then going to be f. Okay, so now that is what we expect, right? The parabola to look like. And let's just move on then to sketch. So they said sketch, guys. So let's just go ahead and draw our axis. So this is then obviously our y-axis. Okay, and then this is going to be our x-axis. Just excuse, guys. This is y and this is x. Okay, so you can start by drawing f, or you can start by drawing the parabola first, the inverse of f. Okay, but let's start by drawing f, which is the original function. But to be able to draw this properly, guys, and also we know that both functions will go through the origin of 0, 0. Okay, so we know that is a point. 0, 0 is a point on our on both our functions. Okay, so let's have a look at the other point that was given to us for function f, right? So for function f, we have the point p, negative 8 and 2. So let's quickly go and draw. So negative 8, we need negative 8 on my x-axis. So 1, 2, 3, 4, 5, 6, 7, and 8. So there we have negative 8, and we have 2, 1, 2. Remember, point P, negative 8 and 2 was given to us that it's a point on function f. So there we have negative 8 and 2. So when we put that point over there, that would be point P. It would be negative 8 and 2. Okay, so now we can see that we have 2 points, right? It goes through the origin, okay? And we have this point. So we can just go and draw this portion of the inverse of my parabola. Okay, so this is then the function f. And there you have answered that part. But let's just quickly look at the theory as well. Okay, so they had told us, right, that our limitation is where x is I don't know why I just did that. But anyway, okay. So our limitation is where x is smaller and equal to 0, guys. So that means x smaller than 0 means the negative side of the x-axis. Can you see that's exactly what is happening over here? Okay, so we drew it on the negative side of the x-axis. Okay, and then let's just go and look at theory over here. A bit of theory from this is from your book, by the way. So can you see that they tell you in your book that when you have a function with a square root, when you have a function with a square root and there is a negative value underneath your square root, guys, which was what we had, right? Because we have a square root of x over negative 2. So can you see what we have under our square root is negative? So this is definitely applicable. Okay. And the limitation they gave us in the test was this limitation that x should be smaller and equal to 0. Okay, so can you see why? Because when x is 0, y equals the square root of 0 divided, that would give you the square root of 0, which is 0, and that exists, okay? And then also they say 0 and everything smaller than 0. So let's, for instance, just put in the place of x a negative 1. Can you see why they say that we always have to put a negative value at the top? Because that would give me a positive answer inside of my square root, which would actually that would actually then give me the answer of this. Okay, it would give me a positive answer. So the answer for y would always be positive, and that is why over here they say y would be greater and equal to 0. Can you see here it is equal to 0, and then for all the negative values that we replace it with, that they say over here, we will always get a positive answer, and that is why. Can you see x should be smaller than 0? So we would be working on the negative x-axis, and y should be greater than 0. So we would be working on the positive y-axis, and that is why we draw it over here. Okay, that is why it falls in this quadrant on the Cartesian plane. Okay, so do we understand? This is in your book, by the way. Okay, so it's all about the square root that gives us these limitations, and that helps us where to draw this inverse of the parabola. Okay, so now that we have that, now it's easier to go and draw the parabola, but we have some work to do because point P, negative 8 and 2, is actually a point on F, right? So that is a point on F, but we need the inverse of this point. So that means we need to change the y and the x value to get the point on the inverse of the function. Okay, so do you understand this? So to get a point on the parabola, we just swap around the x and the y value to get the inverse of this point. And then we have a point to draw on the parabola as well. So it would be 2 on the x, so 1, 2, and negative 8 on the y. So 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Now, when we plot that coordinate, it would be over there. And then this is then the inverse of P, which will then be 2 and negative 8. And that is how you get your point on your parabola. And then you just go and draw, because we know it goes through the origin. Okay. We know it goes through the origin. Okay. So we know that that is then how it's going to look. Okay. So that is then called the function, which is the inverse of f. Okay, so can you see that your parabola could have technically gone on over here as well? Okay, but remember, because we have our limitation, in the previous question, we said our limitation is that x is greater and equal to 0. So we will only be drawing the the greater, the positive side of the x-axis, okay? Not the negative side. So not this part of your parabola, only the part that is under the positive side of your x-axis, okay? And there you have drawn f and its inverse with its limitations as well. Okay, perfect. Okay, so 3.4, if P is reflected in the line y equals -2, guys, so reflected in the line y equals -2, they ask for the coordinates of P accent, which is the image of P for 2 marks. Okay, wait, let me actually just yes, let's leave it yellow because you guys usually struggle to answer this. Hopefully, after this explanation, this would be green marks for you in the future. Okay, so point P, remember what point P is. Point P is what we've been working with this whole time. Point P is -8 and 2, which was given to us at the beginning of the question, right? So this is point P. So they say if this point is reflected in this line, what would the coordinates of the image of P be? Okay, the image of P. So I'm going to draw a Cartesian plane, okay, to make sense of all of this so that you just understand um, how to answer this question. So let's just quickly draw that. The first thing that you need to do is you go and plot point P. So let's say -8 is over here and 2 is over there. So that would be then the coordinates or where you would plot point number or point P, which is -8 and 2. Okay. Okay, so that is the actual point. So start with the point itself, and then you go and draw the line. Go and draw the line y equals -2. Let's go and draw that in a different color. So -1, -2. So this is where -2 is. So let's draw a line that passes through where y equals -2, and that's obviously going to be a horizontal line. And then you write that this line is the line y equals -2. Okay, so that is the reflection line that we will be working with, okay? So basically, you have to reflect this point P. You have to reflect this point P in this line, okay? So in other words, this point will be reflected in this line. Okay, so basically your x value will stay exactly the same. Can you see when we go down, it will be reflected on the other side of this line, then it would still be the same x value, which is -8. Okay, so that is one thing that you can write about this is that it would be -8, of course. Your x will remain -8. We just need to determine where how many places we are shifting from point P to my line of reflection, and then apply the same number of spaces on the or below my reflection line. Okay, so we are currently at 2 places above my x-axis. So when we move down, when we want to see how many places we need to move down to my reflection line, sorry, you just count that, okay, there we are at 1 and there we are at 0, okay? That is two places down, okay? And then another 1 down to get to -1 and another 1 down to get to -2. So from your point, you need to move 4 positions downwards to get to your reflection line, okay? So from your reflection line to point P, it is 4 places that you have to move up, or from point P to your reflection line 4 down. So it doesn't actually matter. It just means that if it's 4 places to point P, it should be 4 places, 1, 2, 3, 4, to your image of P, right? To your image of P. Okay, and we already said that it would remain within the x value would remain -8. So we just need to know what the y value is going to change to. So over here we have this orange line over here is -2. So when we move down 4 places, so in other words, 1, 2, 3, 4 places, this would be -3, -4, -5, and -6. So can you see that this point would then be the y value would then be -6, and that is your answer, right? That for the image of P, the x value would have remained the same, but the y value would have changed to -6. Okay, so that is then your final answer for these 2 marks. We will get 1 mark for the -8, realizing that it's a reflection. Basically, in a shifted x-axis, it shifted down 2 places to be at y equals -2. So therefore, your x value remains the same, and your y value will change depending on the number of places that you need to move above and below your line of reflection. Okay, so that is your answer. Now, before I move on, let's quickly just see. We will see that this question, right, only had, let's just write this. Okay, so over here, I expect 2 out of 2 for 3.1. And over here, at the inverse, I would have expected that you might have lost 1 point if you did not consider your limitation. That's why I made it yellow. And then over here, you would have maybe plotted point P, and some of you, I would expect that most of you would have lost 2 marks over here if you didn't study properly. Guys, this is basically just from my experience, okay? And then over here, some of you actually get 0 for this, but let's just say that you had the -8 correct, so 1. So that's negative or -1. So let's see what you should have gotten out of 11. So it's 2, 4, 6, 7. Okay, so this was easy enough, even though there were a few challenges, taking into consideration what you guys struggle with. I would say that you would get round about 7 out of 11. Okay, so let's just quickly write that down. So that then means that 7 out of 11 is what I would have expected for someone who really studied, who's not mathematically inclined, but studied and knows all of their principles. And that would then give you 64% for this specific question. Okay. Perfect. So for question 1, we said 80%. And for question 2, that was thus far the most difficult question, the sequences and series, which was a 54% expectation question. And then for this one, it is a 64%. If you had studied everything that you needed to, and you know all of your principles, but you just made a few mistakes due to the fact that you aren't mathematically inclined, it would have been, I would have accepted, basically achieving 64 and above would have told me that you really studied for this question. Okay.